Hello everyone, welcome to the channel Learn Math with Shobita. Today I am discussing some questions from real analysis. First question, let X be a compact space and A be an arbitrary infinite subset of X. Then which one of the following statement is true? First one, A has no limit point in X. Option B, A has infinitely many limit points in X. Option C, A has at least one limit point in X. Option D, A has countably infinite number of limit points in X. We have the following theorem. A set is compact if and only if every infinite subset of the set has a limit point in the set. So since A is an infinite subset of a compact set X, A has at least one limit point in X. Therefore, option C is correct. That is, A has at least one limit point in X. This statement is true. Next question. A function f from R to R is defined by f of x is equal to x minus square bracket x, where square bracket x stands for greatest integer function of x. Then, which of the following set can be a set of discontinuities of f? Given f of x equal to x minus x. Okay, so we have to check at which points the function is discontinuous. Okay, for x equal to 0, the function value is 0, and for x ranging from 0 to 1, the greatest integer function the value will be equal to 0, then f of x will be equal to x. Therefore, the graph of the function will be like this. For between 0 to 1, the function f of x will be x, so the graph will be y equal to x. Next, at x equal to 1, it is function value is 0. It's the greatest integer function's value is 1. So 1 minus 1 you will get it is 0. From 0 to 2, the function will be x minus 1. Okay. So graph will be like this. Next, at x equal to 2, function value will be 0. Between 2 to 3, the function is x minus 2. The graph will be like this. So set of discontinuities of this function is integers. At each integral value, the function is discontinuous. Therefore, set of discontinuities of f is the set of integers. Hence, option C is the correct one. Let un is equal to sin n pi and vn is equal to 1 plus 1 by n into cos n pi. Then, which of the following options is correct? So, let us check whether un is a convergent sequence. Given un is equal to sin n pi, which is equal to 0, this is for all n. Therefore, limit n tending to infinity of un is equal to 0. Therefore, sequence un is convergent sequence. So, option A is the correct one. Next, Vn is equal to 1 plus 1 by n into cos n pi. We have cos n pi equal to minus 1 to the power n. So, Vn is equal to 1 plus 1 by n into minus 1 to the power n. Is equal to minus of 1 plus 1 by n if n is odd, is equal to 1 plus 1 by n if n is even. Therefore, limit n tending to infinity of infimum of Vn is equal to minus 1 and limit n tending to infinity of supremum of Vn is equal to 1. So, limit n tending to infinity of supremum of un is equal to limit n tending to infinity of infimum of un is equal to 0. So, here limit n tending to infinity of un is equal to 0, but limit n tending to infinity of un is equal to minus 1. They are not equal. Limit supremum of un is equal to 0, but limit supremum of vn is equal to 1. So, this inequality also does not hold. And last, limit infimum of un is equal to 0 is greater than limit infimum of un is equal to 1. So, option D is correct. Options A and D are correct. Let A be the set of all irrational numbers in the open interval minus 1, 1. Then what is the options? Option A has maximum but not minimum. A has both maximum and minimum. Infimum of A equal to minimum of A. Both supremum of A and infimum of A exist. Given A is the set of all irrational numbers in the open interval minus 1, 1. So, clearly for each x belongs to A, we have minus 1 less than x less than 1. Thus, minus 1 is a lower bound of A and 1 is an upper bound of A. we have the following result. Every non-empty subset S of R which has an upper bound has the supremum. Every non-empty subset S of R which has a lower bound has the supremum. Clearly, A is the non-empty subset of R because A is the set of all irrational numbers in the open interval minus 1, 1, and it has a lower bound minus 1, upper bound 1. Hence, by the infimum supremum property, A has supremum and infimum. So both primum of A and infimum of A exist. Option D is correct. Further, A does not have maximum and minimum. Okay, we cannot here, since a set of irrational numbers is dense in R, we cannot find a maximum and minimum number. Okay, so option D is the correct one. Next question. Limit extending to infinity of x into ln of x plus 1 by x for x greater than 0. So we have to evaluate this limit. Let us evaluate limit extending to infinity of x into ln of x plus 1 by x. If you directly put x equal to infinity, you will get infinity into infinity form, this which is an indeterminate form. So I will moderate expression like this. So into x can be written as divided by 1 by x. So this expression ln of x plus 1 by x whole thing divided by 1 by x. Now also we get infinity by infinity form. So I will apply L'Hopital's rule here. L'Hopital's rule differentiate numerator and denominator separately with respect to x. So differentiating, this is 1 by x plus 1 by x, that is x by x plus 1 into differentiation of this. Apply the quotient rule for differentiation. So you will get this as x minus 1 by x square. One derivative of 1 by x is minus 1 by x square. So this x square gets cancelled and you left with the limit extending to infinity of x by x plus 1. So this you will get the limit as 1. Okay. So option B is the correct one. Next question. Let Q star be the set of all irrationals. Then interior of Q star is option A R, option B Q, option C Q star, option D empty. So let us find the interior of Q. Let P belongs to Q star, that is set of all irrational numbers. Let P be an irrational number. Then there exists no epsilon 0 such greater than 0 such that P minus epsilon comma P plus epsilon is contained in Q star. Okay. So what do you mean by interior? Interior is set of all interior points of a set. Okay. When we say that a point is interior point of a set, a point is said to be an interior point of a set if an open ball containing the point is completely contained in that set. Okay. So here P minus epsilon comma P plus epsilon is an open ball, which is, so we cannot get such an open ball which is completely contained in Q star because the interval P minus E comma P plus epsilon contains infinitely many irrationals. Okay. Between any two irrational number, there is a rational number. Therefore, P is not an interior of Q star. Therefore, Q star has no interior point. Therefore, interior of Q star is empty. So similarly, if they have asked find the interior of rational numbers, interior of real numbers, so some results, some list of interiors here. The set R is open, therefore interior of R is R. We know that if set is open, then interior of that set is equal to set itself. Okay. Interior of Z is equal to empty because Z is not an open set. Interior of Q is also empty. Interior of R minus Z is R minus Z because Z is closed. So its complement R minus Z is open. So its interior is itself. Next, interior of N is empty. Interior of R minus N is R minus N itself. Okay, it's because R minus N is open. Next question. Let Q be the set of all rationals. Then the only connected subsets of Q are. Okay, so we have to here find what are the connected subsets of Q. A non-empty subset X of R is connected if and only if X is an interval or a singleton. We know that set of rationals is subset of a real number set. Therefore, singleton subsets of Q are connected. Okay. They're all 1 points. Therefore, all 1 point sets are connected. If we select a subset containing 2 points of Q, then between it is not connected, because between any two rational numbers there is an irrational number. Okay, so we cannot get other connected subsets. So only connected subsets of Q are singleton subsets. So option all 1 point sets are connected is true. Next question, limit n tending to infinity of n by square root of square root of nth root of n factorial to the power minus 1. Okay, these are the options. So this I have already evaluated using Cauchy's first theorem on limits. See the calculation while pausing the video. I will not explain once here. Here I am applying Cauchy's second theorem on limits. Cauchy's second theorem on limits. According to Cauchy's second theorem, limit n tending to infinity of an to the power 1 by n will be, you will get limit n tending to infinity of an plus 1 by an. Here this is inverse, so it can be numerator will become denominator and denominator will become numerator. Then the after calculation you will get the answer is 1 by e. Therefore option B is correct. Next question, what is the summation from n equal to infinity log n by n? Option A 0, option B non-zero real number, option C infinity, option D log 2. So let us check whether the series converges or diverges. If it is converges, then where to it converges we have to check. If it is diverges, then its sum is infinity. Okay. So let un is equal to log n by n. Let vn is equal to 1 by n. We will apply limit comparison test here. We know that series vn is series 1 by n, which is a harmonic series, and it is divergent. Now limit n tending to infinity of un by vn, you will get limit n tending to infinity of log n, which is equal to infinity, which is not infinity. Therefore, both un and vn either converge or diverge. But here series vn diverges. Therefore, by limit comparison test, series un is equal to series log n by n diverges. Okay. Therefore, its sum is equal to infinity. Hence, option C is correct. Its sum is infinity. Next question, if A equal to the set containing x1, x2 and so on xn, which is subset of R, then which of the following is true? We have to evaluate here A closure. Here A is equal to, which is a finite set. We know that every finite set is a closed set. And for a closed set A, we have A closure is equal to A. Therefore, here A closure equal to A and A is contained in A closure. Both options C and D are correct. Here this A is a finite set and every finite set is closed, and for a closed set A closure is equal to A. Also here A is contained in A closure. For both the options are correct. Thank you friends. Please share and subscribe the channel. If you like, please like the video.